Hello YouTube and welcome back. I am Benjamin Williams and today we're going to be doing another lab within Boson NetSim. And today's lab is going to be on exploring and configuring switch access ports. So let's go ahead and read our objective for this lab right here. It says, in this lab, you will learn how to curate, configure, examine, and delete VLANs on a switch. You will also learn how to configure an interface to be an access port and how to assign the interface to a VLAN. Trunk ports between switch 1 and switch 2 have already been configured. So if we take a look at our lab topology down here, we can see that from the end of that sentence, that switch 1 and switch 2's Fast Ethernet 01 interfaces are configured to be trunk ports between these two switches. And if we look at our topology, we can see that this Fast Ethernet 011 interface on switch 1 is going to be an access port. Same thing over here on switch 2's Fast Ethernet 011 is going to be an access port. And then our Fast Ethernet 012 interface on switch 1 is going to be an access port. And the same thing over here on switch 2's Fast Ethernet 012 port is going to be an access port as well. And that is because they're connecting out to end devices. As we can see, these are PCs, okay? So let's go ahead and read our commands for this lab. We have configure terminal, which enters global configuration mode from privileged exec mode. We have enable right here, which enters privileged exec mode. We have end, which ends in exits configuration mode. We have exit, which exits one level in the menu structure. We have interface type number, which enters interface configuration mode. We have interface range, starting port, ending port, which enters interface configuration mode for a range of interfaces. We have IP address subnet mask, which assigns an IP address or subnet mask to an interface. We have name, VLAN name, which configures a name for a VLAN. We have ping IP address, which sends an ICMP echo request to a specified address. We have show interfaces type number, which shows interface statistics. We have show interface status, which displays the line status of an interface. We have show VLAN brief, which displays parameters for a VLAN, contains the VLAN name, status, and ports assigned to it. We have shutdown, no shutdown. Of course, shutdown disables an interface and no shutdown enables an interface. We have switch port access VLAN ID, which assigns an access port to a VLAN. We have switch port mode access, which configures an interface as an access port. And we have VLAN number, name, VLAN name, which curates or configures a VLAN with an optional name. All right. So let's look at our device interfaces and also IP address and subnet masks that we're going to be using for this lab. We can see that switch 1 is going to have an interface within VLAN 10 and VLAN 20. And we can see that the IP addresses for VLAN 10 is going to be 192.168.10.1, and the IP address for VLAN 20 is going to be 192.168.20.1. And if we take a look at our subnet mask, we can see that we're going to be using a /26 subnet mask, which is 255.255.255.192. All right, so that looks good. All right, so if we we're going to configure these IP addresses on these devices so we can have a management IP address to be able to either telnet into switch 1 or SSH into the device to make some configuration changes. And it's also creating an SVI so we can make sure that we have connectivity within the network so we can ping from switch 1 to other devices within the same subnet. So it's always good to have an SVI configured on the switch. And we're going to have the same thing down here on switch 2. It's going to have both VLANs, VLAN 10 and VLAN 20. And instead of .1, this is going to have .2. So 10.2 for VLAN 10 and 20.2 for VLAN 20. And they're going to have the /26 subnet mask as well. If we take a look at our sales PCs, they're going to be in the .10 subnet, which is VLAN 10, and there's going to have an ending IP address of .11 for sales 1 and .12 for sales 2. And then HR1 is going to be in the 20 subnet, and it's .20.11 for HR1 and .20.12 for HR2. And they're going to have that /26 subnet mask as well. All right, so let's go ahead and get into our lab task. And we're going to be doing our lab readings right here at the top right. We're going to keep our topology in the top left, and we're going to be doing our configuration down here at the bottom, okay? So task 1, it says configure VLANs. It says in this task, you will learn how to create, name, examine, and delete VLANs. You will also learn how to configure a VLAN with an IP address. So let's go ahead and read number 1. It says a VLAN is a network virtualization mechanism that enables a layer 2 switch to function as multiple virtual switches. Traffic within one VLAN is isolated from traffic in all other VLANs. VLANs are often used to segment networks by function rather than location. Based on the devices in this network topology, which devices should be placed into the same VLAN? Well, we just mentioned that. If we go back up here to the IP address information, we can see that the sales 1 PC and sales 2 PC will be within the same they will be within the same VLAN, and the HR1 and HR2 PCs are going to be within the same VLAN. And that is because those are two different departments within our company. And because of that, we do not want traffic to be able to be seen on one part of the company and not seen in another part. So the sales traffic should be separated or segmented from the HR communication. We do not want those two sections within the company to be able to see each other's information on the network. So we will segment them out, okay? So it says right here, on switch 1, issue the command necessary to create VLAN 10. At what point is the configuration in VLAN at one point is the configuration At what point in the configuration is the VLAN actually created on the switch? Sorry about that. All right. So let's go to switch 1. Let's do an enable. Let's do a configure terminal. And let's do a VLAN 10. All right. So this VLAN has not been created yet because we have not typed exit. So if I do a do show, I got caps on. If I do a do show VLAN brief, we do not see that VLAN that we just created. But if I do an exit and I do a do show VLAN brief, now we can see that the VLAN was created. So we have to type in that exit to exit VLAN configuration mode in order for this VLAN to actually be created within our CLI, okay? Or within our device. All right, so let's go to question number 3. It says on switch 1, issue the command necessary to determine the name assigned to VLAN 10. What is VLAN 10's current name? Well, if we take a look, we can see that VLAN 10's current name is VLAN in all caps 0010, okay? So let's go to number 4. It says on switch 1, issue the command necessary to change the name of VLAN 10 to sales. What final command should you issue from VLAN configuration mode so that the change takes effect? All right, so if I do a VLAN 10 name, we want to name it sales. All right, get some context sensitive, and we type that in. So again, if we do not type exit, this change will not occur. Well, let's go ahead and type exit, and now let's do a do show VLAN brief. And as you can see, the VLAN 10 has a name, and it is now sales, okay? So let's go ahead and move on to question number 5. It says on switch 1, issue the command necessary to create VLAN 20 with the name HR. What alternate commands could you have issued to perform the same task? All right, so let's go back here and let's do a VLAN, keep hitting caps for some reason, VLAN 20 name HR, and of course let's type exit to confirm that. And the alternate command that we could use is we can just type the VLAN 20 and then go into interface configuration mode for the VLAN and then put name HR. Let's look at what Boson is going to say. It should then lay it out for us. Yes. So this is what I do. I like to type it all in at one time with one command. But you can, right here, you can see you could type VLAN 20 and then you could do name HR. So it's really up to how you want to put the VLAN name in. I like to do it all within one command though. So now, number 6, it says, on switch 1, issue the command to display the list of VLANs that have been configured on the switch. Do VLAN 10 and VLAN 20 display the correct names? So if we do a do show VLAN brief, we can see that they do display the right names. VLAN 10 has the name of sales and VLAN 20 has the name of HR. All right. So now it says, on switch 2, issue the commands necessary to create VLAN 10 with the name sales and VLAN 20 with the name HR. So let's go over to switch 2. Let's give an enable. Let's give it configure terminal. And let's do VLAN 10 name sales. Sales. Exit. And let's do VLAN 20 name HR. Exit. All right. So now we have did that. So it says on question 8, it says on switch 2, issue the command to display the list of VLANs that are configured on the switch. Which VLANs have been configured on switch 2? So if we do a do show, boom, back up right there, go right here. If we do a do show VLAN brief, we can see that we have the VLAN 10, which has the name of sales, the VLAN 20, which has the name of HR that we created, and it looks like another VLAN was automatically on this device when we loaded the topology, and it is VLAN 30, and it has a name of testing. So we did not configure this VLAN right here. We just did 10 and 20. All right. So it says right here, question 9, it says on switch 2, issue the command necessary to delete VLAN 30. What configuration mode is the device placed into after you issue the command? So let's do a no VLAN 30 name testing. All right. And now it says what configuration mode are we in? We're still within global configuration mode. All right. So it says number 10, it says on switch 2, issue the command necessary to confirm that VLAN 30 has been deleted. So if I do a do show VLAN brief, we can see now we only have the 2 VLANs that we created, which is VLAN 10 and VLAN 20. VLAN 30 has now been deleted on this device. All right. So it says VLANs can be configured with an IP address by creating a switch virtual interface SVI in interface configuration mode. On switch 1, configure VLAN 10 with the IP address 192.168.10.1 with the subnet mask of 255.255.255.192. What is the purpose of an SVI? So the purpose of an SVI is to have an interface within the same VLAN so we can ping other devices within the same VLAN, but also it gives us a management IP address on the device. So if we want to telnet into the device or SSH into the device, we can. All right. So let's see what Boson, well, let's do the configuration first and then we'll read what Boson says. All right. So let's go into interface, VLAN 10. Let's do an IP address of 192.168.10.1, 255.255.255.192 for the subnet, 192. Oops, I did that on switch 2. So let's do a no IP address of 192.168.10.1, 255.255.255.192. All right. And let's do a do show IP interface brief. All right, so that's good. Now we want to do this on switch 1. Sorry about that. So let's go into interface VLAN 10. Let's do an IP address of 192.168.10.1, 255.255.255.192. All right. So let's read what the purpose of an SVI is on Boson. It says an SVI enables a Cisco switch to communicate with other devices on a VLAN. When an SVI is configured on a layer 3 address with a layer 3 address, the SVI address can also be used as a means for connecting to the switch for remote management. So that is exactly what I just explained, okay? So now it says on switch 1, issue the command to display detailed information about the VLAN 10 interface. Has the interface been configured with the correct IP address and subnet mask? How is the subnet mask represented in the output? So if I do a do show interface VLAN 10, we can look at the IP address information. We see we have an IP address of 192.168.10.1, and it is represented, the subnet mask is represented in CIDR notation because it says /26 instead of dotted decimal. All right, so that looks good. All right, so it says right here, question 13, it says on switch 1, issue the commands to configure VLAN 20 with the IP address of 192.168.10.2 and the subnet mask of 255.255.255.192. What happens and why? So let me think this is an error within Boson because it says .10.2. Just looking at this on switch 1, maybe it's telling me, oh, okay, it says what happens and why. So it will give us an error, and it'll basically say that the IP addresses are going to overlap. Yeah. So I think it was just giving us this this instruction so we could see the error. I already know that the error was going to occur, but it says right here, it says the switch indicates that the network you configured for VLAN 20 interface resides on an overlap with the network on which the VLAN 10 interface resides. Each VLAN is a separate network, therefore devices on each VLAN should be assigned IP addresses in separate subnets. So it basically just told us to do this so we could see this error right here. All right, but it looked off to me as soon as I seen it. So let's go ahead and move on to question 14. It says on switch 1, issue the command to configure VLAN 20 with an IP address of 192.168.20.1 and the subnet mask of a /26. So yes, that's what we want to do. So let's do an exit. Let's go to interface VLAN 20. Let's do an IP address of 192.168.20.1, 255.255.255.192. All right. And now that is done. So now let's go to switch 2. It says on switch 2, issue the commands to configure VLAN 10 with an IP address of 192.168.10.2 and the subnet mask of a /26. And it says configure VLAN 20 with an IP address of 192.168.20.2 and the subnet mask of a /26. So let's go over to switch 2. Let's give an exit. Let's go into interface VLAN 10. Let's give an IP address of 192.168.10.2, 255.255.255.192. Let's go exit, and let's go into interface VLAN 20. Let's do an IP address of 192.168.20.2, 255.255.255.192. All right, so that looks good. And now let's do a do show IP interface brief, just to confirm that we have the correct IP address information, and we do for VLAN 10 and VLAN 20. Let's do the same on switch 1. Let's do a do show IP interface brief. We do have the correct IP address information for VLAN 10 and VLAN 20. All right. So let's go ahead and move on to task 2 for this lab. It says configure access ports. So it says in this lab, you will learn how to configure a switch interface to be an access port and assign the interface to a VLAN. You will also learn how to shut down access ports that are not connected to any other devices. It says, for number 1, it says from sales 1, ping sales 2, which has an IP address of 192.168.10.12. Is the ping successful? Why? All right. So the ping should be successful, but let's go ahead and go to sales 1. And let's do a ping to 192.168.10.12. And the ping is successful. And the reason that ping is successful is because sales 1's port that it connection to switch 1 on is still within the default VLAN 1 interface on switch 1. And the same thing on switch 2. the fast Ethernet 011 port on switch 2 is also inside of the VLAN 1 default VLAN. And as we remember, if we remember from the start of the lab, switch 1 and switch 2's fast Ethernet 01's ports are connected as a trunk port. So these PCs are able to communicate with each other. All right. So let's go ahead and move on to question number 2. Now, let me scoot you guys over just a tad bit. I think my camera got hit whenever I got up. But now it says, by default, a switch interface is configured to negotiate whether it is an access port or a trunk port. An access port is a port that sends traffic on only one VLAN. A trunk port is a port that sends traffic for multiple VLANs. On switch 1, configure the fast Ethernet 011 interface to always be an access port. What are some benefits of manually configuring a switch to be an access port? So a benefit of configuring a switch to manually be a access port is, so if a end user connects into the switch, it will always be an access port. It will not try to negotiate that port at all. And that way, a rogue switch cannot be plugged into a port on a switch and then be able to create a trunk. And if that happens, then you have trouble. Somebody can cause havoc on the network. They can do attacks such as VLAN hopping and etc. All right, so let's go ahead and do the first step that it said, and then we're going to read Boson's explanation on why we should always configure switch ports to be an access port if it is an access port. Okay, so let's give an exit on switch 1, and we can go into interface fast Ethernet 011. All right, and then we do a switch port mode access. All right, and let's read Boson's explanation. It says, one benefit to manually configure a port to be an access port is that the port will no longer attempt to negotiate a trunk. Therefore, if a malicious actor were to connect a rogue switch to the port, the switch would not be capable of participating on the network as a switch. And yes, that is correct. That is kind of what we just explained earlier. All right, so let's go ahead and move on to question number 3. It says, by default, access ports are assigned to VLAN 1, which is the default VLAN. On switch 1, issue the command to configure the fast Ethernet 011 interface so that it is assigned to VLAN 10. All right, so now we are already on the fast Ethernet 011 interface. Let's do a switch port access VLAN 10. All right, now it says for number 4, it says on switch 1, issue the command to confirm that the fast Ethernet 011 interface on switch 1 is assigned to VLAN 10. So if we do a do show VLAN brief, we can see that now that fast Ethernet 011 port is connected into the VLAN 10 VLAN. We can see that from this output, okay? Now it says, from sales 1, ping sales 2. Is the ping successful? Why or why not? So let's go to sales 1. And this ping should not be successful. And that is because we just changed this fast Ethernet 011 port on switch 1 to be within VLAN 10, but we have not did the same on switch 2's VLAN 011 port, which connects out to sales 2. So switch 2's fast Ethernet 011 port is still within the default VLAN, which is VLAN 1. So they are not going to be able to communicate with each other. But let's just confirm it with the ping. And as you can see, we're getting these request timeouts now. So that does not work as expected. All right, so let's go ahead and move on to question number 6. It says, on switch 2, issue the command necessary to configure the fast Ethernet 011 interface so that it is explicitly configured as an access port and assigned to VLAN 10. All right, so let's go to switch 2. And let's do an exit. Let's go into interface fast Ethernet 011. Let's do a switch port mode access. Switch port mode access. All right. And let's do a switch port access VLAN 10. All right, now it says give the topology about 30 seconds to converge, and then from cells 1 ping cells 2. Is the ping successful? Why or why not? So this time the ping should be successful, but before we do that, let's just do a do show VLAN brief to give it some time to converge, the network time to converge. And as we can see, that fast Ethernet 011 port is now connected into the VLAN 10 VLAN. So that looks good. Let's go to cells 1 now and try that ping. And yes, that ping is now successful to cells 2. So question 8, it says on switch 1 and switch 2, issue the commands to configure the fast Ethernet 012 interface so that it is especially configured as an access port and is assigned to VLAN 20. So let's go to switch 1. Let's give an exit. Let's go into interface fast Ethernet 012. Let's do a switch port mode access. Let's do a switch port access VLAN 20. Do the same thing on switch 2. Let's do an exit. I'm going to interface fast Ethernet 012. Let's do a switch port mode access and switch port access VLAN 20. All right. Now it says on switch 1 and switch 2, issue the commands to confirm that the fast Ethernet 011 interface and the fast Ethernet 012 interface are each configured to the correct VLAN. All right, so let's do that. Let's do a do show VLAN brief. And we can see that the fast Ethernet 011 port is connected to VLAN 10, and the fast Ethernet 012 port is connected to VLAN 20 on switch 2. Let's confirm that also on switch 1. Let's do a do show VLAN brief. And we can see that the fast Ethernet 011 port on the sales PC is connected into VLAN 10, and the fast Ethernet I'm sorry, I said 012. The fast Ethernet 011 port is connected to VLAN 10, and the fast Ethernet 012 port is connected to VLAN 20. So that looks good. So it says from HR1 ping HR2. Is the ping successful? And it should be. All right, let's do a ping to 192.168.20.12. I mean, as you can see, those pings are coming back as successful. Let's move on to question 11. It says on switch 1 and switch 2, issue the commands to display VLAN information. Which interfaces on switch 1 and switch 2 are not connected to any other devices? So if we look at these devices on switch 1, these are in the default VLAN, so they're most likely not connected to any other devices. And if we go to switch 2, we can see also the same ports and in the default VLAN. But we can also do this command. We can do a do show IP interface brief. And all of the ports that are in the down status and also in the down protocol means that no devices are connected to these devices. So that is fast Ethernet 02 through 012. All right. And probably be the same thing on switch 2. Let's do a do show IP interface brief. And we can see that the fast Ethernet 02 and 010 interfaces are in the down state. All right. So let's go to question number 12. It says access ports that are not connected to any other devices are security risks because rogue devices can connect to them and communicate on the network. Issue a single command on switch 1 to shut down these interfaces. Do the same on switch 2. All right. So we just said it's the fast Ethernet 02 through 010. So if we do an exit, we go into interface range, fast Ethernet 02 through 10, and we do a shut on all of those. Let's do the same thing on switch 2. Let's go an exit. Let's go in interface range, fast Ethernet 02 through 10. Let's do a shut. Let's do a do show IP interface brief to confirm that. And all of those are now shut down. Let's do the same thing on switch 1. Let's do a do show IP interface brief. And those are all administratively down as well. All right. So now it says on switch 1 and switch 2, issue the commands necessary to ensure that interfaces that are not connected to any other devices are shut down. And we just did that. So hopefully we did everything correct. That is the end of this lab. Let's go ahead and grade. And yes, we did everything correctly on this lab. So thank you guys for watching this one, and I'll see you in the next one.